The current target for the open world game is to see if I can handle each cube representing 1 meter and then be able to handle a planet, so all 6 sides, where kilometers is the target. Hey, everybody. It has been a little while, and I have gone down a rabbit hole. All right, what you see me playing right now is a little video game I'm making to demo what I can pull off. It is running a bit slow. I apologize for that, but I will be working on it over the next period of time to make this demo a lot more impressive. So this is your classic Minecraft game. Look out in space. Cool. Now, the novel part I'm working on with this game is more about how I'm using AI in a novel way to try and push the boundaries of what you can pull off with a vibe coded game. So obviously I'm not creating any of the 3D assets here. They're all AI generated. Now, as you may recall, I started this to see if I could figure out how to use open source Claude. During that process, I found that building games was by far kind of the best test cases. Let me show you this future. Build a ship here. Cool. Switch this over here into that mode. All right. Great demo. Love it. All right. So I'm just going to pretend like that spaceship totally worked. And now I'm in space. So the fun part about my little Minecraft world here is I was trying to do a merge with No Man's Sky. So you can travel the universe, go to all these different planets. All the planets are obviously cubes floating in space. You can see this is the one I was on, but there's a whole bunch of more ones like here. And then you get the whole No Man's Sky thing where you can travel from one solar system to the other. And they'll have different, like this one's got a binary star. Some will have 3 stars, some have 1, different classes. That affects all the procedurally generated content. And then you can create and destroy stuff on them. And of course, it's a massive multiplayer game, so I can just send you a link and you play my game. Right? Still very much in progress. And I'll let everybody know as it becomes a little bit more usable and realizes some of this vision. This has been taking me, I think, about a month now that I've spent on it. And you can tell it's still got a bunch of rendering issues. And it is challenging to build. So this is definitely pushing the limits of vibe coding. Oh, here, let me show you one last thing. Yeah, let's see what happens if I try and land on one of these moons. I suspect it will not work for me, but we'll give it a shot. What's happening? Is it gonna work? Is it gonna work? Oh, come on, you can do it. Yeah, you see the little red progress bar thing? That's me slowly landing. Let's see if we can get out. I'm on a moon. It's going to slowly try and build the scene around me. But now I'm stuck. I didn't do a proper land, so. All right. So you can see the game's making progress. I will give everybody updates as it progresses. Oh, by the way, that was all running in a web page. I'll include the link so anybody who wants to can just open it up and try it out. If you want to build a game, this hilariously huge stack of horrible problems. Okay. Whenever you're building a game, it's this huge stack of horrible problems. And it's very, very difficult to automate most of these steps. So the premise here is to kind of look at how you can change like the stack fundamentally to inject points where it's easy for AI to understand what's going on so it can debug it himself. Okay. So that's how you make it AI first. All right. Yeah. You want to build a AAA game? Good freaking luck. You got to have a ton of cash. All right. None of that money is being spent on a cool game concept. Right. That costs nothing. All right. It's all about this huge loop, trying to generate assets, iterate on the design, go back and forth. And it's very, very difficult. Okay. The loop for building a game breaks in a few key parts, right? So anytime you do any testing, you got to look at it and then describe it, and then another human's got to reproduce that. Never going to happen right. So it's incredibly hard to analyze the bugs. There's a bunch of platform improvements that have tried to focus on this problem, but that's a core problem. Even when you have a clear bug description, it tends not to be something you can reproduce because the stack games are built on isn't inherently deterministic. It tends to be this built on this, right? That creates non-determinism, makes it very difficult to reproduce. When you change things, it's very difficult to identify those mistakes, so regressions become invisible. Tuning is incredibly difficult, and attention always goes into the wrong parts of the game. All right. The core concept of this whole AI first vibe coding game thing is you turn a game into data. Okay. So it's not pixels on the screen. You do not want to try and debug with screenshots, right? That's just a nightmare. And then you got to make it so that the game is deterministic. So it doesn't matter if it's run headless or on the best hardware in the world, the core sim state needs to be predictable. So that way I can just get a few key data points from the current game state, and then I can reproduce exactly what happened on my own machine. All right. So IR, intermediate representation, is we take each of the components that make up a game, right? So the nodes, the hierarchy, the sim, the physics, the rendering, the audio, a bunch of semantic concepts, what's the character up to, some perf metrics, shove all of that into an intermediate representation that we can send around. Skip ahead here. So there's for instance, the human complains, character's mouth doesn't move when it speaks. The AI sees that description, plus it sees this little JSON thing that says mouth flat while speaking. It gives you the tick numbers. It tells you which channels were being operated inside of the face rigging, what the audio was trying to do at that time, what the weights were. That is trivial for it to test, right? It knows how to understand that. Okay. So verify everything on the GPU. That's not particularly interesting. You don't build new features until the AI is able to understand what's going on. Okay. So each layer of the stack, the physics, the characters, the world, everything needs to render content in a AI first data format that can then be snapshotted and sent back whenever feedback is reported. Oh, and I didn't highlight the most important thing. Run it in my browser, please. There's a little feedback button right here. You click it and it generates feedback. If you click on it while playing my game, it generates feedback about the game using this system so that I can actually fix whatever you don't like in my game, right? And don't just limit yourself to this is broken. Feel free to describe whole new features that you want, and it'll take the context of what you're doing and use that to inform. So give me feedback, all right? All right. Moving on here. So the sim, you have to use random number generators. It's in JavaScript. You have to switch out the math engine. There's a whole bunch of nightmarish things you got to do. But when you do that, you get a deterministic sim that whether or not it plays on your phone or a desktop computer or my headless Chrome simulator, they will generate exactly the same numbers at every single stage, which shockingly, JavaScript doesn't actually do by default. Little things like cosine don't work consistently. The random number generator system doesn't work consistently. So I got to build a bunch of math libraries that can then be used to generate a predictable sim so that therefore I can share all this data and debug it. You miss any of these things, everything's going to blow up. So there's a bunch of random math events, et cetera, in the system that are very, very difficult to make reliably work across every system. So I have to add all these extra linting checks to make sure that those don't get introduced and force it to use the deterministic ones that are built into the system. So that's another core feature of this gaming platform, right? Linters, verified on real hardware, right? So did a whole bunch of cross text to make sure that this actually is deterministic on every JavaScript library. Make so that the save state can be forked. This is just helpful so you can replay, try different paths. Really good for game exploration. Trying to build an AI that could play World of Warcraft from beginning to end would be difficult. Getting one to say, let me start at like 30 minutes of the game and then go explore alternative paths of the best way to build out a base. That becomes more achievable. And that's what this is. This concept I originally explored for the typical apps, like my Ink app, my Love app, go break my app, or come up with 1,000 new ideas for how I should improve my app. So I built a whole system where it runs a swarm of AI bots against my app, analyzes those and analyzes the results and generates something. And for web apps, it's fairly easy. It's got this deterministic HTML state that it can look at and makes it pretty easy for it to debug what's going on, determine if it likes the way it looks, create UI suggestions, all the standard stuff. This one, I'm doing the same concept, but in the world of gaming. You give a task like build a big city or create a complicated factory, right? So you have AI agents that can run on your game and then generate game specific feedback, right? So for the one I was showing before, the world game, I had it go enter the ship, fly the ship into space, make sure that there's no frame drops, that thing. And I just tell it those instructions and it figures out how to test that at each step. And because it's got all this deterministic intermediate representations, the IR, it's able to analyze it without relying on screenshots or looking at the GPU mesh, which is good freaking luck. All right, cool. More and more and more about the game engine. Let me skip ahead. This is getting long. So I tried to come up with the perfect way to test if the game platform actually can't hit AAA level. I'm not going to demo today my factory sim, but I do have a factory sim that I've also built. Uh, I, I'm using that as part of the test case. So it's a factory sim, the world building, and then a first person shooter, right? And that's to hit like some of the core AAA difficult test cases. So I did some initial testing. This is not what the game looks like, trust me. Just to see, can the predictable deterministic sim actually handle like absurd scale? Like, could it build Factorio? So did some initial testing to see if it can actually do that and maintain like a 60 frame per second sim, right? Not the rendering. The rendering can run way over 60 frames, but the sim system. So like this is a plate moving along a belt. All right, feedback report. Like I said, download my browser. Just go to uglybot.com, go download it, please. Anytime you're writing my apps, click that feedback frequently and often. It'll make the product way, way, way better. Player feedback. And tools that go right against the app, they do the same thing. They actually just generate the same feedback system. All right. And you can see this is the kind of process it goes through when it receives the feedback to go and break it into pieces, figure out what actually went wrong. All right. So every time you give me feedback, I capture enough about the state that I can reproduce that exact situation locally. So I don't have to guess how you get there. I don't have to understand what's going on. I can snapshot it and I know exactly what's going on. All right. That's a critical part of the whole loop, right? You need the human because there's a lot of this is subjective, right? It's like, is it fun? Okay. Human only ever sees a build where everything objectively clickable is already green. So there's the process that it goes through of repeating over and over to make sure that all the surfaces, the gameplay, et cetera, are working. And I know my current demo, it's not, and the AI agrees it's not, but it had been over a month since I made a video, and I'm like, I gotta show people what I'm working on. All right. Again, IR, intermediate representation. All right. Yeah, hopefully you hear it. I'm skipping through ahead. I overdid the slide deck. All right. The game system is built on the app system. So the same one I used for making the chat app, the browser itself, a whole bunch of other apps, it is sitting there. And that makes so that a lot of stuff, like if I want to use text speech inside of a game, speech text, any of those systems, they're already built, right? I already have all that functionality. Uh, it's trivial to do like a little chat app, all this typical controls, buttons and stuff, right? All of that's built, done, sorted, ready to go. So you don't have to redo everything in like as 3D graphics. So that gives you a nice solid stack. And a shockingly large amount of game development is actually not in the 3D engine. It's like menus and control systems. Uh, Again, keyword in that feedback telemetry. So that's the whole snapshotting what's going on in the app. Uh, that's critical to making this work. And there's a whole bunch of stuff in like the data schema for the server side that's really helpful. So like the world building game, all of that's using standard schematized like data storage so that it can become a massively multiplayer game and we can all see the same content and share it. And the communication from that to the servers, all WebSockets, it's all running in Cloudflare as workers, right? All of that, like the cron task, everything's necessary to make like the really dynamic, massive multiplayer game. That actually is not actually that unique. That's about the same as like if I want to have two people edit a Google Doc at the same time. It's shockingly similar problem. So that's all core app framework. That's not even game stuff. That's just standard. Just build a web app. Okay. So if I want to do AI again through the same platform, probably we'll explore this in the world building one. We'll see. Really want to explore the concept of taking some of the character AI bot concepts into this world building character thing. So they're not dumb NPCs. They actually are really intelligent NPCs. We'll see how far I can take it. Like the dream would be an NPC can just come up with things it wants to build and it starts crafting things in the world. I mean, should be technically doable, unless I get AI psychosis first. All right. So all your classic game, all the classic 2D UI you'd need already been built for other apps that I have. So you can just reuse it and style it. Okay. Last. I really, really like the idea that I can build a game, works in the browser on the desktop, and I can use it with the gamepad or I can use it with keyboard and mouse. Or I can open it up on my phone, also in a browser, and I can use it in touch, or I can use it with one of those gamepad devices that you use with your phone. This requires something similar to Steam input, where you define, for the vast majority of use cases, you say, I want to use FPS style input, and it just knows the standard best practice, like touch controls, the standard best practice gamepad controls, the standard best practice keyboard and mouse controls. And then you can use the more advanced like things. So I want to do something custom for this specific game. And that would require potentially building a custom touch, pointer, and gamepad interface. So it does all of those. And obviously that's all integrated into the IR. So that data gets captured. Okay. So you can imagine I want to put controls into FPS mode or want to control, or I just want the raw input stream. All right. Support both. Do it more like how a game does input, not how a web page does input. So there's a little bit of mapping because games tend to process input on a per frame basis, whereas most web apps are more request response design. Yeah. So handle both. So the dream, I got a little phone and the desktop, and it all matches exactly the same sim state. Feedback's consistent. It's all reproducible. Every game that you can make for a desktop is playable on the phone. Day one. Massively multiplayer games, half phone, half PC players. Why not? Live in the future. All right. So again, very browser focused. Interestingly, with web GPU, there's very little like you can basically do all the shader stuff. That's a given. you can handle obscenely high triangle counts. That's usually good. What I found surprising is the thing that's actually the biggest limiting factor between web GPU and just a raw desktop app is almost entirely how many draw calls I can do per frame. So you can right now, I'm primarily focused on doing like large grouping of draw calls. So like everything that's opaque and not alpha transparent, you can combine it into the minimum number of draw calls so you can have maximum scene complexity without hurting. And that should get me far enough. One of the motivations I had actually with building the custom browser, right, is that if necessary, there is a fail-safe mechanism that I can use to achieve AAA that would be specific only to my browser via like custom, like directly exposed for functionality that would be only accessible within that browser. I haven't used that yet. It's there if I need it. And I would still consider that a win. All right. But it would mean that I'd have games that could only hit AAA level when played in my browser. We'll see if that's going to be required. WebGPU gets a lot farther than I thought it would ever be able to achieve. So this may not be the limiting factor. But it is something I've considered. We'll hold it off until it hits. But it's there. So, like I said, I'm going for FPS, the open world game, ridiculous open world game, and the factory sim. The current target for the open world game is to see if I can handle each cube representing 1 meter, and then be able to handle a planet, so all 6 sides, where any particular side is at least 131 kilometers is the target. So that's the upper bound I'm trying to see if I can hit. That will require streaming and a whole bunch of things. And that's why you saw my demo was going there. It was having some frame rate hiccups. So there's still a lot to achieve there. It's getting it slowly. It's requiring a lot of advanced optimizations to achieve it. Like the worker that actually does all of the like 3D meshing is not in the same thread as the GPU. It's a separate custom worker thread using like this shared buffer for smuggling data back and forth, which is like nothing you do under normal web development. That would be quite advanced. Similar with the factory sim. So the sim is always a separate thread with shared buffers, but for the world builder, the open one, I had to have yet another separate worker thread just for world rendering. So it's the area of exploration. I don't know how far this will actually go when it's all done, but these are the ones I'm trying to hit. I will continually do demos, and I am planning that this will probably one of the last ones where I'm going to do so much on the PowerPoint side. I think I'm going to transition more into becoming a like game reaction video channel. So I'll be playing the games and reacting to the content and showing off the new features as we go. I'll leave you a little picture here. All right. So it's all coming together, but building a game is hard. So this is definitely an ambitious target. And I would have loved to keep going with the whole open source, like, can it be? But I mean, I'll be honest right now, that battle's done. K3 is fine. Like, there's no reason you can't use it. It does work. I have right now, I have a maxed out plan for K3, OpenAI Codex, and Claude. Because to achieve this current game, I have managed to completely max out the $200 plans, and I'm basically running all 3 at peak. So, and I will tell you, K3 right now, absolutely the worst deal of the batch. Um, they are not subsidizing at the rate that the other two are. OpenAI and Anthropic are crazy subsidized. K3 is subsidized. Like if I were to pay for the actual tokens and the $200 a month plan, it looks like it would cost between $4,000 and $5,000. So I have no idea how subsidized the other two are, but I am able to run. I in Kimi I can run approximately one active coding session. Okay, um, but in the other two, I can basically maintain about 4 active coding sessions during my waking life for a week. Right, so you can get substantially more done in those. Um, yeah. So I'd say open source uh, wins, but it's not a good deal yet. So it is cheaper per token. They're definitely using less computing power for achieving the same result. But because of the current financial like subsidies that are occurring within the Anthropic and OpenAI platforms, you're still much better off just handing them the your $200 and getting back your 10K plus in like token value from them while they're willing to continue subsidizing. Um, I suspect that that won't last forever, and at some point you'll want to have your backup plan ready to switch over to K3 or DeepSeek V4 or whoever. Right? It's a constantly evolving world, and the prices hopefully by the time the subsidies shut down for OpenAI and Anthropic, the open source one has become cheap enough that it doesn't need to be subsidized to achieve the same output as the other ones. They're capable of it already. It's a cost game, right? So it's just how quickly can people drive down the pricing. Um, there's a few. I will say when I get into some of the really advanced cases, K3 just still struggles a bit. And honestly, so does Claude. And I can't believe I'm saying this, but for the hard problems, my go-to is Codex. Like, I did not see that one coming. Um, yeah, when it comes to like, I'm trying to build a custom hair simulator. Codex, man. I tried on Claude. It couldn't do it. It just struggled. It could not figure it out. I had to actually switch the AI system to solve it. Anyway, that has been my long rant on a long video that I've put off for a long time. Anyway, stay ugly. Download my browser. Try my game out. Give me feedback. I would love it. Thank you.